The information economy has arrived. The world is teeming with innovation as new business models reinvent every industry. Inside Analysis is your source of information and insight about how to make the most of this exciting new era. Learn more at InsideAnalysis.com. InsideAnalysis.com. And now, here's your host, Eric Kavanagh.
All right, ladies and gentlemen, welcome to The Future is Right. Yes, indeed, your host here, Eric Kavanagh. It's time for another episode of Inside Analysis, your only coast-to-coast radio show in the U.S., all about the information economy. And we have a truly international show today, folks. We're going to talk about AI on the move, artificial intelligence, getting things done, changing business processes, really leading to innovation. We'll talk to Atif, Syed, he's from a company called Wootzano, and also Francisco Weber from a company called Cortical is dialing in. Atif is in the UK, Francisco is in Austria, and then we'll have Rich Hartmann dialing in from Germany. So true international show today, all about the power of AI. And I'll start us off with my common theme about artificial intelligence, that the common narrative in the media is just dead wrong. It's largely this storyline about how AI is dangerous, it's going to take away jobs, we're not going to have anything to do anymore. And that is just absolute nonsense. I will tell you, there are so many applications of AI. They're changing every day. There are new ones coming out every day. And you see it everywhere. The big cloud giants are all using artificial intelligence. I promise, your Googles and Facebooks and LinkedIns of the world, they're all using AI to optimize some part of some process. And when you talk about sort of standard machine learning style use cases, one of the analogies I will use for folks is that they're kind of like little army ants when they want to get something done. If you think about trying to move a pile of dirt from one place to another, if you have one vehicle, you load up the vehicle, you drive it over and you dump it, you load it, and again, you go back and forth. With machine learning, a lot of times you distribute the job. So it's a sort of federated process where you have 1,000 army ants, each going over and grabbing one piece of dirt and then going back over in their own time and getting it done. So you're really distributing the workload is what it boils down to. So the key becomes, which algorithms do you use? And an algorithm is basically just like a recipe, if you get right down to it. Which do you use and for what purpose? So typically classification is one of the most common use cases for AI, trying to understand, okay, is this an apple or is this an orange? Trying to understand, what's what and how do I organize things? And then also optimizing decision points. So what's the best price for the oranges that I'm selling on the market today? Is it 10 cents? Is it 50 cents? Dynamic pricing is a classic example of artificial intelligence in action, really trying to use as much data as possible. And where this goes, folks, it's really another sort of foray into the world of analytics. If you're trying to understand something, that's the role of analytics. And there are lots of traditional means for doing that. We have business intelligence vendors, for example, who have been slicing and dicing data for decades. But with artificial intelligence, you can have a bit of a broader spectrum and a number of different ways to solve for that problem. So with that, let me bring in our first guest, Atif Syed from Wootzano, dialing in from the UK. Atif, tell us a bit about yourself and your company and how you're using AI.
Thank you so much, Eric. So from Wootzano, I'm the chief exec and founder of the company. So in Wootzano, our aim is to democratize robots. We build very dexterous robots which can do tasks like humans do, but traditionally robots failed. So one of the areas we're applying this robotic system is picking various fruits and vegetables. So we do tomatoes and vine tomatoes and grapes being one of the most complex fruit, even for a human to handle. So what we realized before COVID-19 and before locally here, which we call Brexit, was that there was a big issue with packers trying to get products and trying to pack products to be then shipped to supermarket shelves. So by not having labor to do that, it was one of the most difficult processes, especially with COVID-19, and the labor problem just swelled even further. So having robots was an obvious way to go forward, but there were no robots available. So we used our robotic system, which uses quite a few things on the side. But one of the few unique bits we've done is we have something called an electronic skin or an artificial skin, which replicates what a human skin does and slightly goes beyond human evolution. So it tells how soft or hard a product is, if a product is slipping out of your hand or
Wow.
a robot hand. And then we use all that data, which collects the vision data, the data from the skin, the actual touch and force sensitivity and slipper detection, and feed it back to the robot so the robot understands how to manipulate these objects. And it's not just that. As the robot does the job, it learns over and over again. So the first robot which gets installed in a pack house, to the 1,000 robot gets installed, the 1,000 robot knows everything all the 999 robots before it learned. So there's massive data set of how to manipulate objects, which for humans will take quite a long time, but for robots, because it's instantaneously and it's an ever evolving product, you can, as a customer, keep getting a robot which just keeps improving and keeps adapting in what it's trying to pick. So we use AI and machine learning models to essentially enable these robots to interact and do the more mundane tasks, but requires a great skill of dexterity, like packing, snipping, and picking and placing it into punnets, grapes and tomatoes and wine tomatoes.
Yeah, that's such cool stuff. I did a show last year about a similar topic with a Canadian company actually that uses artificial intelligence to optimize the growing of tomatoes and plants and other things. And one of the really interesting angles that came out of that show was that they learned that sometimes you can't really tell what the bug is by looking for the bug itself. You may not be able to see him, he's underground or somewhere else, but you can tell just by the impact it's having on the leaves. So they have cameras on all these plants. And if you see the leaves start to turn yellow, that means something. If they get spots on them, that means something. And to your point, once the system understands that, it's very easy for a machine learning algorithm to identify those things and to classify it as such, right, Atif?
Absolutely. So once you have some seed data, the model essentially knows what it's looking for. So once it gets a bit of data telling it, oh, that's a grape or that's a tomato of this variety of this from this country, and all those sort of parameters, then the robot knows what it's looking for. However, of course, when it looked at it, it doesn't. I mean, it will take it fraction of a second to know it, like exactly what I mentioned, classify it to this being a grape grown in Peru of a particular variety, or is it something grown in Egypt? And very small differences, even humans, we miss out. The robots can immediately tell, oh, is this the right species, or is it the right varieties, or does it have the right characteristics, what the end retailer actually requires? So that all those understanding and all those information, which gets quite difficult for humans to do, but robots are essentially designed. And that's where they excel massively.
That is so cool. And here again, we have machines doing what they're good at doing, enabling people to do what they're good at doing and not doing what they're bad at doing, right? I mean, one of the key values to my mind about artificial intelligence and machine learning is that it can tackle these very repetitive, tedious tasks with no trouble whatsoever. That's what they excel at. In fact, the more repetitive it is, I think the more aligned it is with the value that AI can bring. And we all know that human beings don't like to do that stuff, and they get very bored and they get upset, and that causes friction. It causes morale to go down, all kind of stuff, right? So the net here, Dr. Syed, is that properly administered AI is going to optimize processes and make people happier. What do you think?
Oh, I absolutely agree with that. I mean, in our sort of robotic systems, we use something called supervised learning, where the robot, all the data which the robot collects, it gets read by or it gets looked by our machine learning engineers, and only if and only we think that's good for what the robots are supposed to be doing, it gets fed back to the model, and model updates itself. It can happen once a month, 2 times a month, depending on how frequently it is. And absolutely correct that humans over time, if you're doing a repetitive task, you may start off at the start of a shift, you might be doing it quite well. Towards the middle of your shift, you're sort of looking at the clock and like, when am I finishing?
Right.
By 7 hours down the shift, you're sort of like, okay, well, the last thing on your mind is, should I continue packing this product, or am I going to be out of this? But the robot, on the other hand, doesn't care. I mean, the efficiency is exactly the same when it started and at the start of the day, and continues to be the same towards the end. It consistently does the same thing. It consistently evolves the way it should be. So I think that element again gives people the luxury of really thinking, and luxury of time, luxury of what they do best, which is creativity, coming up with new ideas, coming up with new ways of solving things, as opposed to essentially doing mind-numbing tasks of just taking something and putting one into another Punex. It's to enable people to actually be more skillful and let robots do those repetitive tasks. And in our robotic system, it's not just it mindlessly picks up, it also makes decision on the fly, and that's all because of the data we collected. So the robot knows a bit of bounding conditions and decides how to pick and how to process. And an interesting point there is, with human philosophy in a way, is that if I put too many rules for a person to say, you know what, I only want you to think in this particular direction. I can put some rules to make sure you don't do something bad, but as long as within a boundary condition of some rules and regulations, you're free to think. Because if you're not free to think, you can't be creative enough. So similarly, with our robots, we do give some bounding conditions to make sure robot doesn't do something completely drastic. But at the same time, you can't restrict that mind for it to be coming up with intelligent ways to actually solve or pick up or process the thing in front of it. So it does all of that whilst giving the people the luxury of time. And I think that's essentially what people need to understand, and that's essentially what we all need to understand and appreciate.
Yeah, the luxury of time. I love that. Well, speaking of, let's bring in Francisco Weber from a company called Cortical.io. And Francisco's company uses artificial intelligence for, well, a slightly different use case, but it's similar in a number of ways in terms of classification. So Francisco, tell us a bit about Cortical and what you folks are doing with AI.
Yeah, so thanks for having me. In fact, we work in the field of natural language understanding. That's the space we feel well. And what we try to do is to make natural language understanding in a different way so that it becomes more efficient. Because among all the disciplines of AI, I could imagine, I mean, I don't know the exact numbers, but it feels as if in language AI, we have particularly large amounts of data that we have to work with, especially if you have to come up with rather complex cognitive capabilities and things like that. Things get expensive in terms of computation very quickly. And making that step so expensive with the functionality you said before classification, that's exactly it. With the ability of classifying text, you can probably solve, I don't know, half of all the use cases out there that are about text and about business decisions and business actions that need to be automated. But if one classifier costs you 100,000 euros or dollars to build, that component that in principle would be needed in every office basically of the company becomes hard to afford. And as a consequence, I think that the number of production grade installations of language AI basically is incredibly small compared to the actual demand that we notice out there when we speak to people and prospect customers and so on. So it has a number of reasons, but I think the main reason in the end is that for more complex language AI, that used to be cost prohibitive so far. For many, let's say, smaller mid-size companies, and even the large companies, they deploy it in a very punctual way on specific high pain points that they have. And I think, or we think, that applying language AI to the degree it's feasible until now should be ubiquitous. Whenever you see someone keeping replying to the same kind of email all the time, forwarding all the time to the complaints department from the company inbox, yeah, at some point you ask yourself, okay, if that exceeds a certain number or volume, that would be much more efficient to actually distribute automatically. And so that's the kind of products we create. And in order to be more efficient, because currently it looks as if the whole field improves the models mainly by making them bigger, which ends up in being more expensive because you need more resources to compute them. We have been going the other way, and we were looking for the most efficient sort of implementation known about language AI, and that's the human brain. And in fact, we figured out a principle that obviously the human brain is using to represent language information. And interestingly, when we applied those findings to the computational side, it turned out also to be more efficient. I mean, biology is known for being the super efficient sort of mechanism. And that was quite an interesting finding. And when we found out that the key feature of our approach is actually efficiency, we realized that all the focus on precision, which normally is made towards AI models, in the case of language, is probably not appropriate, because any model, given enough time and enough resources, can probably end up converging at some point. But the actual feasibility, the practicability of that technology just depends on, can I do this in a reasonable time with some reasonable amount? Yeah, that's our main area. And we work with very different use cases, mostly, for example, analyzing contracts in insurance, for example, recently, and things like that.
And I love that angle, contract intelligence, you call it. And you brought up a couple of good points here. And you reminded me of a question that I've had, which is, what are the most efficient algorithms for different use cases, right? Knowing which algorithm to apply to a particular problem is not a small challenge, and it's really, really important. I kind of think to myself back to my days in calculus, and I remember in calculus, you really have to understand a certain number of formulae and kind of intuit which one to apply to a particular problem. So it's a pretty challenging space. And in that sense, I think it's actually quite similar to applying artificial intelligence to the real world, because Francisco has made a number of really good points here. One of which is that, yes, you can have a complex model that will get to the end result of figuring out how much to charge for this orange versus that apple, for example. But the problem is, if it's a very complex algorithm, it's going to take a lot of resources, a lot of compute, a lot of time, a lot of storage, et cetera. That's going to add up to make it not really viable to do. So you always have to understand, what are the economics of the project I'm working on? What are we trying to accomplish? And then you sort of go down the list and figure out which algorithms are going to make more sense than others. How much data do you have? How much data do you need? It all takes time and effort, but we'll pick this up after the break, folks. Don't touch that dial. You're listening to Inside Analysis.
Welcome back to Inside Analysis. Here's your host, Eric Kavanagh.
All right, folks, welcome back to Inside Analysis, talking to several experts today about artificial intelligence. We already heard from Atif, Syed of Wootzano and Francisco Weber of Cortical. And next up, we have Richi Hartmann of Grafana Labs. And folks, Grafana, I've been tracking these guys for a couple of years now. I consider them to be a true pioneer in what we're calling observability. And observability means what you probably think it does, being able to see what's happening inside these systems. Now, to the non-technical person, that might sound like something we should always have had, but no, we haven't. We have all sorts of new ways to see into information, very large distributed systems, not just log files too, because log files are a very common way of understanding. A company called Splunk, for example, just nailed the monitoring of information systems from a log perspective. That's very good for solving certain issues, but there are lots more complex issues to crack the code on these days, and Grafana is working on that. So Richi Hartmann from Grafana, welcome to Inside Analysis. Tell us a bit about your company and what observability is, and maybe what the different kinds of observability are.
Yeah. Thanks for having me. So when Atif said democratizing robots, that resonated quite well with me. Of course, Grafana Labs is a company founded on the idea of democratizing metrics, and these days also logs and traces as well. Metrics are basically numerical values. Logs are text snippets, and traces are basically the path a computer took through code which it ran. This is super important, as you mentioned, in modern IT or in more complex scenarios, like, for example, cloud native, Industry 4.0, IoT, all those huge data intensive applications. And all of this might sound a little bit abstract, but there's a really high chance that the bank you're using, the shops you buy your food from, the logistics company which actually gets the stuff to you, they're using our systems to keep their services up and running and quick and know when something works and when it doesn't work and what they need to fix. So observability is, if you look at the definition from math, from control theory, it's defined as being able to deduce the internal state of a system just by looking at the inputs and the outputs, nothing else. Which already tells you that you need to have a very large amount of data and you need to have good knowledge about the system. But then once you have that, once you are at that level, you're able to ask pretty much all questions, even questions you didn't know you would be having while the system is running, without the need to stop the system, make changes, have it emit new data or something, and then resume the system.
This is fantastic stuff. And so when you talk about being able to define metrics, and that's something obviously you've built some technology to do, you're able to essentially classify what all those text log files really mean and boil them down to numbers such that people can manage the numbers. And that's what you always do, is manage numbers. Is that about right?
That's a large part of it. So so let's maybe start with logs shortly, and then we go into metrics, and then we go into labels. With logs, is like that's the human language model, which Francisco talked about, where you have snippets of text which humans understand, which is super nice if you have humans which are doing the actual work. And oftentimes, if you have poorly defined systems, that's the only way to actually interact with the system, because humans are designed to work with language. But it's not very efficient to do it that way. So what you have seen again and again and again in history is that humans took language and transformed it into the numbers, into the underlying essence of what they were thinking and talking about. Shipping numbers of old ships. If you look at those logbooks, it's literally just numbers. The speed, the navigation, what cargo they had, it's just numbers. You have the same with power plants, where you don't get a call and they tell you how much power you're using. You just get the number of how much power you've been using. That's how they transmit this information between each other. That's the same for your bank. It's the same for ISPs, where basically 20 years ago, logs didn't scale anymore and they had to do something else. They had to go towards numbers and emit counters about how much traffic is going in on that interface, how much traffic is going out, all those kinds of things, because the plain logs just didn't scale well enough anymore. So you see this again and again and again when humanity encounters huge amounts of data, that they need to reduce this complexity into numbers to just make it more manageable and cheaper, honestly, to work with. But now we have something super nice. We are not dealing with the real world, because I totally get why, like, this is a bunch of grapes, please pick it up, is a super hard problem. The beauty of, or this is a contract which has been written by a random person, please interpret what this actually means. Here we are dealing largely with code which has been written by developers. And they already know certain properties about their systems. So they can already put some metadata onto the data they are emitting before that is even emitted, that data. Then the operators of the software, they know in which environment this is running, on which cloud, which region, what customer this is for, all kinds of information. And this information is also attached as metadata to the data which is being emitted. So at the point in time when we at Grafana Labs, or the users of Grafana Labs, see this data, it already comes with rich metadata attached to it. Funnily enough, we call this labels. In AML, you also call this labels. It's slightly different. So for us, it's just key value pairs of information which we attach. The AIML definition is humans have looked at the data and verified that metadata and applied it. But it's roughly equivalent in as much as you can use this as a really, really good basis to put your AIML on top of that systems data. And that's what we are doing at Grafana Labs with our AIML effort, where you can do things like we look at historic data and we can say, okay, this is an outlier, or this is a thing which you might want to be looking at. We predict that your load in this and that scenario is this and that, so you need to provision X amount of resources more. Or going into IoT and Industry 4.0, this thing has a different property. I don't know, that motor is spinning slightly differently from all the other motors. So you do predictive maintenance on that cooling unit or what have you. Of course, you know this is out of the norm. And as you said, Eric, it's like if you distribute this task to a lot of different hands at the same time, like you have tons of little eyes just looking at all the little bits and pieces in the system, that's where, from our perspective, a lot of the AIML power is lying.
Yeah, this is really good stuff. And, you know, I was on a show a few weeks ago talking about analytics and AI and so forth. And I threw out an interesting question, which is, it's kind of fun. I'll throw it over and see what you think about this, Richie. But when you're looking at data sets and you see the outliers, it seems to me the outliers are typically either the story or they are what needs to be removed to understand the story. In other words, sometimes the outliers are mistakes, or it's just the model was set up wrong, or it's bad data, for example, or there's just something that happened, like, oh, we put all this data in at once on that date, but ever since then it's been steady. So sometimes the outlier is distorting the view, but sometimes the outlier is the signal itself. What do you think about that, and how would you handle that from an AI perspective?
That's one of the hard problems. So
Right.
if you look at people who do actual statistical analysis of large data sets, if you look at people who do empirical analysis of studies and such, usually you cut off the outliers above and below, because it gives you a lot less noise in the resulting signal. And hopefully it is signal after you cut out that noise, because as you say, maybe that thing is the signal.
Right.
It depends on specifics. Sometimes you can easily just cut them out and you're fine. And sometimes you shouldn't really. And that's the other part of AIML as far as I see it. It's not there, at least not in all areas, to replace humans. It's there to augment the abilities of humans, to support subject matter experts, whatever field they might be, to actually make a deduction that, yes, this is correct. Hey, this smells funny. Please take a look. Raise an alarm, have a human take a look. If you have systems which can become automated away completely, you obviously need to solve those problems. But usually most systems which I've seen are designed specifically with humans in mind as kind of an escalation path. Just ideally with fewer humans who don't have repetitive tasks. You don't need as many. They don't need to stay up late. They can be woken up if something really bad happens. But usually you're supporting humans, not completely replacing humans. Fast forward a few years, you're starting to see more and more replacement.
Yeah, that's very interesting. And, you know, you guys are, of course, big open source proponents. I think that's how this all got started. And I've been a huge fan of open source for a long time. And real quick, since we have you on the show here, how big a deal is the open source movement? Because I view it as deeply game changing and enabling, because for lots of different reasons. One of my favorite lines is, many eyes make few the errors, so you can find bad code, like bad code goes away. But also just the collaborative side of this equation, because what you're tackling is an issue that is salient for just about every organization out there. So by taking this open source approach, you're really able to build out this foundation and grow this community, which I think has largely led to your success. Can you talk about that for a minute?
Sure. So myself, I've been in the open source scene for more than 2 decades now. So I strongly believe in open source.
Yeah.
with my Grafana hat on, that's the first time I actually being paid to work on and with open source. Like no, on open source with was the case before, which is super nice. From the Grafana perspective, there's two main driving factors. A, it's the right thing to do. It's kind of the ethical thing to do, which like gets us super deep into philosophy and into the weeds. And obviously, a company does not solely exist to give away everything for free. That's
Right.
We like the concept of food and shelter, so earning money is nice. Yet that is part of this, to just try and do the right thing in general. The other part is this is obviously also a sales driver in the sales motion, because we have a large installed base of users who are already familiar with our products and our projects. They know how to operate them. They know that they're reliable. They know the ins and outs. So if you're approaching a company and they tell you, hey, we already implemented this and we just need a support contract, or we need more storage, or what have you, that's a relatively easy sale. In a different scenario, we had the CTO in a call and they were like, yeah, I'm using this to monitor my garage when it's open, when it's closed, how hot it gets. Why are we even talking about this? Let's just buy it. Because the CTO already knew the in and out of Grafana, which is super powerful. But it also means you're not monetizing like every last user, you're just monetizing a fraction of the users.
Yeah, and I see that you have Kubernetes support. We talk about Kubernetes on this show quite a bit. K8s, as some people call it. And the best description I've heard of Kubernetes is that it's distributed compute. And basically it encapsulates little system processes that are required at some point. So you launch the little container, the pod, it goes, it does its thing, and then it disappears. Sometimes you do have to bump them if they get hung up on something, obviously. But Kubernetes does greatly complicate the enterprise computational landscape, I suppose. Tell us real quick how you're able to help companies use that technology effectively and efficiently.
So first of all, Kubernetes is great, but it's not for everyone. Like if you're just running your own web shop or your own personal blog, unless you want to tinker with it, you most certainly don't need a fully horizontally scalable blah, blah, blah.
Right.
Having a random web server is completely fine and defensible. It's arguably the right engineering trade-off. That being said, in particular, if you're going into cloud native, if you're going into highly dynamic workloads, if you need to scale out horizontally, if you need many, many different people who have ownership of many different microservices, and all of those need to be orchestrated and need to be talking to each other and not just hit the wall, you need an orchestrator, and that's where Kubernetes shines. We have it relatively easy at Grafana Labs, because one of the main things which we are supporting is Prometheus, which is also a CNCF project. I'm also a Prometheus maintainer, and Grafana Labs is investing heavily in Prometheus. If you look at where Kubernetes is coming from, that is basically the equivalent of Google's Borg, which is their internal orchestrator, and which allowed them to grow as much as they did. And the counterpart to this was Borgmon, or well, that's too detailed. Anyway, Prometheus is basically Borgmon. And even though those two projects have been started separately from each other, from their history and from the people who actually created those projects, they were inherently designed for each other and made with each other in mind, because both of them assumed the other side to be there.
Interesting. Prometheus, I've taken some briefings from those folks too, from some of the folks who are working on that project. Another fascinating project to tackle challenges at scale, right? So we're trying to enable this cloud native world, because what are the businesses and consumers all want? They just want to hop online and have stuff work. They don't want to have to worry about some of the devil in the details underneath. So the work that these folks are doing on open source projects like Prometheus, like Kubernetes, are hugely impactful, because again, they save time and money, and they also allow specific organizations to focus on their strengths and not have to worry about building out a monitoring system, for example, for incredibly complex systems. But folks, don't touch that dial. I'll be right back. You are listening to Inside Analysis. All right, folks, back here on Inside Analysis, talking all things artificial intelligence. What a fantastic panel of experts we have today from all over Europe, as a matter of fact. And Atif, Syed, I'll throw it back over to you of Wootzano to talk about the power of AI and really these open source movements that I think are really fundamentally changing the game. If you think about where we were, let's say 20 odd years ago, the major pillars of the enterprise software world were all closed source, or primarily. I mean, IBM has put a lot of time and effort promoting open source way back to the early days of Linux. And now it has really crawled up and across the stack, and it's all over the place. Atif, I'll throw it over to you. What do you think about the power and the future of open source for enterprise computing?
Yeah, absolutely. I mean, a few years ago, in terms of when people are looking into, I think one of the biggest questions people asked was, how will you make money out of open source? And if we keep giving products away for free, how exactly are gonna get money? So, for instance, if you look at what Red Hat is doing with Linux and essentially in terms of the revenue they're generating, it's not about closing the software, because the software inheritedly, there's not much you can do in terms of protecting that bit. The more important value behind the software is how exactly you're putting your bit on top of it. So for example, if I take example what we do, apart from of course the normal things we use something called ROS, which is Robotic Operating System, which is an open source set of libraries. The simple way to put this is not really an operating system per se, but it's in a way which allows us to control every bit of the robotic system, and it allows us to get those in one little package, or not one neat package. So rather than asking one part of the hand or other part of the hand to talk to each other seamlessly, ROS enables that platform or language to be in place. So if, for instance, companies like us, if we didn't have ROS, if that didn't exist, and if it wasn't open source, the development we then ended up doing using ROS, everything else we did on top of ROS is ours. But the fact that ROS on its own continues to be open source, it's a huge benefit, not just to us, but for everyone else. So what we do, our developers, they'll also help write and modify and edit the ROS code so that and it's not just because, oh, well, someone else is benefiting from it, but actually by this unified pool of information coming into making ROS better, it's enabling us, which otherwise as a company, we would be putting all of our time, resources, money, and everything trying to just make ROS work rather than solving problems with it. So
that's right.
So the way we see it is that by having open source data and by having open source code, you're able to exponentially increase the time it takes to get your products out to market. So that's where we've seen it. Obviously, people use things like Android. If again the Android base code wasn't there, you wouldn't be having pretty much almost everything towards your modern mobile phones. Because Samsung takes it and puts their own bit on top, but the kernel and everything else remains the same. So it's exactly sort of the same ideology where why do you help open source? Is because it helps everyone else.
That's
and
right.
Let's help that, so that we don't need to worry about writing the fundamentals and start solving problems.
Yeah, that's right. And to explain to our audience here, when we talk about open source, what we mean literally is making the source code available for review and examination and use. There are different licenses around that. And the reason that's important is because in the old days, let's call them, there's still a lot of closed source software. The company would keep the code that is used to compile the application for certain targets, like for your phone or for your PC or for your Mac or something like that. Once it's compiled, the cake is baked, basically, and it can be hard to understand how you got the recipe there. But with open source, you kind of open the kimono and let everyone see. And Francesco, I'll throw this over to you of Cortical. Since you're doing natural language stuff, look at the natural language translation engines that are now being provided by Google to just go in any language and just do a translation. Now, they're certainly not always perfect. There are some rough edges, but what a stunning revolutionary innovation to be able to just allow someone now, if you're in a foreign country, take out your phone and speak your words into the phone, tell it to translate into Italian and show it to the person in Venezia, una città molto bella. Like, okay, it's a beautiful city, Venice. That's great. We can all communicate. And I think lots and lots of problems, lots of friction that occurs in the business world, and of course in the broader world as well, stems from misunderstanding and miscommunication, right? If people did not communicate effectively about what was going to take place, and then the game changed, that's when people get upset. So the more you can work on trying to understand does this contract mean, what does this language mean, the better off we're all going to be. What do you think about all that, Francisco?
Yeah, so that's definitely astounding if you see the average quality of a state-of-the-art machine translation system today. And it's also interesting that you better mostly get all of the code you need to do this. You can download it for free in various open source communities and so on. The interesting thing is that now this whole talk about open source versus closed source from the beginning of the millennia, sort of, when the generation change from the closed source vendors started. And I think what we can assume as an outcome of that period was that especially infrastructure software is in fact of a better quality when it is created by a large community than even by a large company. Can never reach that point of quality in something like an operating system or a web server and those fundamental building blocks that are built. But now it seems that we have a second revival of that whole conflict. Because it's now about open and closed source corpora or training materials. I mean, you can have basically the same program, let's say approximately, as Google is using for their really excellent machine translation system, but you can't have the data to actually train it. In fact, if you want to be or to implement a top state-of-the-art machine translation system, I would guess there are maybe 5-6 companies left who can afford doing this. Yeah? Many super large companies simply cannot afford doing this. So they have to actually either become users, so they have to license that material, which again has a lot of issues because you will, of course, get probably nicely priced English training material. But if you want to use Lithuanian training material, it's probably not even out there in those amounts. Yeah. So there will be, again, sort of the contrary of a democratization. It will be a specialization, and people have to live with whatever the market is open to give them. So there again, I think getting this whole machine translation model training to use, let's say, 1 million times less data, which would be a form of efficiency, right. Suddenly everybody could start training a machine translation model, and you could train I don't know, if you happen to be an old Mercedes aficionado, you could train your own little language model that perfectly applies to your domain, and you could give it away for others who would be interested in this. So a whole other, a bit like we see with video content and YouTube, as soon as there is an easy way of providing content, people are more than willing to provide content. So I'm pretty sure if training models about something you are an expert on becomes sort of easy, people will also appreciate sharing those and looking at everybody's models and how well they do on a certain task. But for that, there has something similar like this community concept of the open source era has to come into this model and data world also.
Yeah, and you brought up something very interesting, and maybe we'll do this in the podcast bonus segment today, but Francisco brought up a really good point here, which is that, and I see this everywhere in the open source community, people want to share. They want to share what they've built. They want people to understand because they get excited about it. They're like, look, I solved this problem. Let me post this code and explain what it does. You're starting to see this in the whole cloud native world with site reliability engineers. For example, we've talked to some interesting companies like Shoreline.io recently, which are really sort of building out platforms to deal with reliability issues. And in the podcast bonus segment, I'll talk to Richi Hartmann here of Grafana Labs about how they're really help their clients optimize systems. Think about when you're like, oh, the system is going slow today. Anytime you're on the phone with someone at a big company, like, hold on, just give me a second, because they're waiting for the system to operate. There are all kinds of reasons why that happens, but the kind of metrics that Grafana Labs can help you get access to, they can help you really expedite the resolution of those systems much faster, much easier. That improves morale. We'll be right back. Inside Analysis. Okay, folks, time for the podcast bonus segment here on Inside Analysis. What a fantastic show. We've been talking to Atif Syed of Wootzano, Francisco Weber of Cortical, and Richi Hartmann of a cool company called Grafana Labs. And I'm on your website right now, Richi, looking at some of these use cases like Salesforce and Siemens. I mean, these are big, big companies, TripAdvisor, for example, and just to kind of paint the picture here, when you're dealing with large enterprises that have very complex systems, technologies that they use to deliver their services or their products or whatever, trying to get to the bottom of really sticky issues that are hindering performance can be, it could be a never-ending process, basically. And so this is where Grafana really excels. And it's in part because they have so much information. They have an open source project. They've gathered so much data on so many different kinds of systems. And this is always the question in my mind. I'll throw it over to you, Richi. You can learn from how this system A interacts with system B, A, B, and C, C, A, and D, all these different combinations of things. You can collect the kind of data and transform it into metrics that can really expedite the process of determining what's wrong and then fixing what's wrong. Is that about right, Richi?
Pretty much, yeah. I mean, it has many different aspects. There is the something is on fire, this needs to be fixed right now aspect, and basically drilling down into your data and doing the firefighting to figure out what is wrong. That's most certainly one of the large aspects. I would say the next large group is just visualizing data in a way which enables humans to understand how the system should normally behave. To basically get an understanding of what a normal operation looks like, which makes it a lot easier to debug when you are in abnormal operation situations.
Interesting.
Planning, capacity planning, which is particularly important for all the large companies because they grow at insane rates and their data keeps exploding. And arguably the most important bit is alerting. There you have automated systems. They look at your data, they look at what's coming in, they look at the status of your complete fleet of whatever you have, and then yell for human interaction or for intervention at the precisely correct time, which means the people on call get enough sleep, they get to have a family life, they get to go to the movies. But also the customer does not lose any connectivity, any service, any what have you. The business does not lose money because people can't buy stuff, and getting this precisely right. That's the large group, I would say.
Yeah, and I'll throw this back over to you real quick, Richie, and then we'll get final comments from our other guests. But you talk about alerts, and just so people understand what that means. Alert is anytime there's something wrong and you get an email say, hey, the system is down, something's going on. The challenge with alerts, it's kind of like what we talked about earlier today on in a different perspective, but the challenge with alerts is if they're too fine-grained, if they're too sensitive, then you get way too many alerts and you don't pay attention to them. If they're not sensitive enough, then you miss big problems, and that's a huge issue. So finding the middle ground, that's the hard part. And what I'm seeing on the front of innovation today in that space is when an alert flashes, the system involved will do some additional analysis and look around, okay, how serious is this alert? Let's check this system, check that system. You look for patterns of behavior. And then once the alert is delivered to the end user, it's not just, hey, the system is down. It's more like this system is down, but this system is still up. And we think it's this and we think it's that. So you really help the the person responsible for putting the fire out know what kind of fire it is, where the fire started, all these different aspects. It's a grease fire, it's an electrical fire, whatever the case may be. Those details are really, really valuable for being able to facilitate the remediation of that problem, right, Richi?
Yes. I mean, this doesn't fit into here completely, but the super quick version is you need to package little amounts of complexity, of required complexity, into services which have clearly delineated service boundaries. So you know what needs to be delivered outside of whatever this is, a database, what have you. And then based on those, you can define certain properties which must be hit or not be hit. Those would usually be called SLIs, service level indicators, which are measured against service level objectives. And if you need to start paying, that's when you break the service level agreement. The point here is it's not so important if a system is down, at least not for the alerting use case. That's more for the debugging use case. The only things you should be alerting on to avoid pager fatigue and avoid burning people out is to alert on anything which is currently or imminently customer facing, nothing else. The customer doesn't care if 3 of your SQL databases are down or not. They literally don't care. They care that their web shop is up and running.
That's right.
And that's the kind of thing which you need to alert on. What you just said is precisely what you then need for the debugging. Of course, you need to know this and that service which is underlying under my service is down. That database is having issues. That data center is down. That region in this and that cloud provider has this and that problem. Like those kinds of things to drill down into your problems and find out what you actually need to be fixing. But on the alerting side, only stuff which is actually or imminently customer facing or impacting.
Yeah, that's good advice. And Atif, Syed, final comment from you. I'm sure you've got lots of alerts in with those robots. Like say, oh, the grate broke. Go ahead, real quick.
Hopefully not too many alerts, but not absolutely right. An alert is as good as, it's like crying out fox. Like, oh, I've got a fox. And you say it once, twice. Absolutely true that people eventually says, actually, I keep getting this alert. Is that really a problem I should be reacting for? In talk about work from home, when the pack house managers and people who work in managing the packaging sites, they never thought their work could be potentially done from home because now if you have robots, they actually have no one to manage. And these robots are connected over the cloud, so you can actually see live feed each of the robots, what they're doing. So by having alerts which are directed to them, to the pack house manager, saying that actually the robot is down, exactly the way you said it, we don't just go and say the robot is down, but actually what impact it has on the actual production you're supposed to be carrying out on the day, and what potential remedy actions you can take to resolve that. So an alert is not just telling the person, here's the problem, but actually providing a solution. So we do that rather than just giving out texts and pings on your mobile phone that your robot is down.
That's great stuff. Well, folks, we've run out of time here, but we'll get these gentlemen back on sometime. Look these guys up online. Atif Syed from Wootzano. That's Wootzano. Wootzano, I think. And we have, of course, Francisco Weber from Cortical.io and Rich Hartmann from Grafana Labs. We'll talk to you next time, folks. You've been listening to Inside Analysis.